Hello everyone, in this video we're going to explore topic 5.10 and 5.11 optimization problems. Alright, one of the most common applications of calculus involves the determination of minimum and maximum values. Consider how frequently you hear or read terms such as greatest profit, least cost, least time, greatest voltage, optimum sign, least sign, greatest strength, or greatest distance. Before outlining a general problem-solving strategies for such problems, let's look at an example. Alright, example number 1. A manufacturer wants to design an open box having a square base and a surface area of 108 square inches. What dimension should the box be in order to produce a box with a maximum volume? Alright, so we have two things to consider. The first one is primary equation. Primary equation is what the question asks you to do, which is the maximum volume, right? And the second one is the secondary equation, which is what's given, right? So it's given 108 right here, right? So you have the primary equation is the volume of the box, right? So this is a rectangular prism, right? So the volume should be length times width times height, right? So V equals this guy same, right? So it could be S squared times height right here. Now the secondary equation is the surface area of the rectangular prism, which means you're gonna add the area of all faces up, right? Because this one is an open box, right? So we don't count the top, right? Now from this secondary equation, we're going to solve for h, and then we're going to substitute that one into the primary equation, right? So I have h equals 108 subtract s squared over 4s, right? Alright, so the primary equation becomes v equals s squared times 108 minus s squared over 4s. The goal is we just create an equation with one variable, right? Previously, this equation contains two variables, right? Now we're going to simplify this one, so this guy turns out to be v equals. Now we're going to take the derivative of this one, so v prime equals 27 minus 3 4s squared, right? We let this one equal to 0, right? We solve for s, so I have s squared equals 36, then s equals 6. Now we have two values right here, it could be plus and minus 6, right? Since the side length of the open box right here should be positive, right? So we exclude negative 6, right? Now we're going to use the second derivative test to determine the maximum values, right? So I have v prime is right here. I need to calculate v double prime. Negative 3.5 s, right? So v double prime of this critical number right here, 6, is negative 3.5 times 6, right? It's going to be negative 9, which is less than 0, right? So by the second derivative test, s equals 6, the volume is maximum, right? And the dimension should be 6, and h right here equals this one, right? 108 minus 36 over 24. It's gonna be 3, right? So finally the dimension is 6 by 6 by 3. Now let's move on to the next one. The guidelines for solving apply minimum and maximum problems. The first step is identify all given quantities and quantities to be determined. If helpful, make a sketch. Step number 2, write a primary equation for the quantity to be maximized or minimized. Step number 3, reduce the primary equation to one having a single independent variable. This may require the use of a secondary equation, which is given, right? Step number 4, determine a feasible domain for your primary equation. Step number 5, determine the design maximum or minimum value by using the techniques discussed in topic 5.4 and 5.5. Note, this includes taking a derivative, finding critical numbers, and setting up a charge. Alright, now let's take a look at example number 2. Which points on the graph of y equals 4 minus x squared are closest to the point 0, 2? Alright, so this problem involves minimizing distance, right? Alright, first we need to sketch the graph of this guy, right? So this is gonna be a parabola, right? The y-intercept equals 4, so it could be right here, which is the vertex, right? And then the x-intercept equals plus minus 2, so it could be right here, right? So it's gonna be something like this. Now we need to find a point on the graph which is somewhere right here, x and y, right? And the point 0, 2 right here, such that the distance from here to here is shorted, right? So I'm going to use the distance formula, right? Because we're trying to minimize the distance, right? So that is the primary equation. So the distance formula between 2 points is going to be square root of s minus 0, right? This point is 0, 2. So s minus 0 square plus y minus 2 square, right? Now I'm going to square both sides, so it could be d square equals s square plus y minus 2 altogether squared, right? Now this one is the primary equation, so keep that in mind. The secondary equation is right here. Alright, so from the secondary equation, I need to solve for y and I substitute into the primary equation. So I have d squared equals s squared plus 4 minus s squared minus 2 altogether squared. I need to simplify this one. So d squared equals s squared. Now 4 minus 2 is going to be 2, right? So this guy turns out to be 2 minus s squared altogether squared, right? Now I need to take the derivative both sides with respect to s. So it's going to be 2d times d prime equals 2s plus, this one I'm going to use the general, right? So I have 2 times 2 minus s squared times negative 2s, right? Now divide both sides by 2d, right? So I have d prime equals 2s divided by 2 is going to be s, right? So I have s right here. Now this guy 2 is gone, right? So I have negative 2s times 2 is going to be negative 4s. Negative 2s times negative s squared is going to be positive 2s cubed, right? Over d. But d equal this one right here, right? So it could be square root of s squared plus y minus 2 altogether square, right? Now s minus 4s could be negative 3s. Now I need to find critical number, right? So critical numbers e squared d prime equals 0 or undefined, right? So negative 3s plus 2s cubed equals 0, right? Now I need to factor s out, so I have s times 2s squared minus 3 equals 0. So I have s equals 0, s equals plus and minus root 6 over 2, right? And second one, d prime is undefined when denominator equals 0, but denominator cannot be equal 0, right? So we just ignore it. Now we need to use the side charge, right? So I need to draw the number line right here. Negative root 6 over 2. This one root 6 over 2, and it's gonna be 0 right here, right? Now right here we have a 0, 0, and 0. Now I need to test the interval, right? So I'm gonna pick a number within any interval, right? So I'm gonna pick a number 1 right here. Then I substitute 1 for s into d prime right here. Now I need to check the sign, right? So I have negative 3 plus 2 over the bottom always positive, right? So I don't need to worry about the bottom. So the top equals negative 1, which is negative, right? So this guy is negative. And I keep changing the sign. This one is positive, this one is positive, and this one is negative, right? F prime is negative, this one is decreasing, increasing, decreasing, and increasing. The minimum is right here and right here, right? Now you need to conclude that the minimum values occur at s equal plus and minus root 6 over 2 because f prime changes sign from negative to positive at these 2 points. Now you need to find the coordinate of these 2 points, right? So you need to substitute s equal plus and minus root 6 over 2 back to the equation right here to solve for y, right? So I have y equals 4 minus s squared, right? So it's gonna be 4 minus plus and minus root 6 over 2 squared. So it's gonna be 4 minus 6 over 4, right? So it's gonna be 10 over 4, and simplify it's gonna be 5 over 2, right? So you have 2 points, it's gonna be negative root 6 over 2 comma 5 over 2. The second one root 6 over 2, 5 over 2, and this one is the final answer. Now let's move on to example number 3. A rectangular page contains 24 square inches of print. Alright, so this one is the secondary equation, right? Because it's given. The margins at the top and the bottom of the page are to be 1.5 inches. And the margins of the left and the right are to be 1 inch. What should the dimensions of the page be so that the least amount of paper is used? Alright, so this one is the primary equation, right? Now, it involves the area of the page, right? So we know that the distance from here to here is y, which is right here. The distance from here to here is s, which is right here, right? And then we have the secondary equation is s times y equals 24, right? Now the primary equation is the area of the page right here. It's gonna be y plus 2, right? The left margin is 1, the right margin is 2, so y plus 2, right? And the top is 1/2, the bottom is 1/2, total is 3, so s plus 3, right? Times s plus 3, right? And this one is the area. Now from the first equation right here, I need to solve for y, right? So y equals 24 over s. Substitute this guy into the second equation right here. So a equals 24 over s plus 2 times s plus 3, right? Now I need to multiply this one out. So this guy turns out to be 24 plus 72 over s. Now 72 over s, can I write this one as s power of -1 so that I can take derivative easily, right? Now 2 times s, it could be 2s, right? And 2 times 3, it could be 6 and 24, it could be 30, right? Now I need to take the first derivative, right? So I have a prime is going to be negative 72 s raised to the negative 2, right? Plus 2, right? And then I will write this one as a fraction. It's going to be negative 72 over s squared plus 2. Now I need to let this one equal 0 so that I can find the critical number, right? So then 2s squared equals 72. And then s equals plus and minus 6, right? I only pick s equals 6, right? Because the dimension of the base always positive, right? Now the critical number occurs when a prime is undefined, right? So a prime is undefined when s squared right here equals 0, right? But you know that the dimension cannot be equal to 0, right? So there is no value of s, right? Now I need to use the second derivative test to test for the minimum value, right? So I have a double prime equals 144 over s cubed, right? So then a double prime of 6 is going to be 144 over 6 cubed. It's going to be greater than 0. It tells us that the function obtains a minimum value, right? By the second derivative test. You have s equals 6, you need to solve for y, right? So I have the formula right here. So y equals 4, right? Now you need to answer the question, what should the dimension of the base be so that the least amount of paper is used? Which means they're gonna ask you to find the whole thing right here, right? It's not just s and y, it's right here. So you need to add 2 to y and 3 to s, right? So finally it's gonna be plus 3, it's gonna be 9, right? Plus 2, it's gonna be 6, right? So the dimension should be 9 by 6, right? This one is the final answer. Now let's move on to example number 4, optimization on a closed interval. Now let's move on to the next one, optimization on a closed interval. Example number 4. Two posts, one 12 feet high, this one right here, 12 feet high, right? And the other 28 feet high, this one right here, 28. Stand 30 feet apart, so the distance from here to here is 30 feet. They are to be steady by two y's, right? The first y right here, the second y right here, which is y and z, attached to a single stake right here, running from ground level to the top of each post. Where should the stake be placed to use the least y, right? Which means minimum, right? Use your calculator. Alright, so we need to determine the primary equation and the secondary equation. Alright, so the primary equation is right here, w equals y plus z, right? Now secondary equation is, now I need to use Pythagorean theorem in each right triangle right here to solve for y and z, right? Right here. Alright, so y squared equals 12 squared plus s squared, right? Then y equals square root of 144 plus s squared. Now z squared equals 28 squared plus 30 minus s altogether square, right? Now z equals square root of this one. Now I substitute z and y into the primary equation, so I have w equals. Now we're gonna bring up the calculator to take derivative of ws, right? So go ahead, store the equation first. You're gonna hit w of s, and then hit control and this button right here. next to number 9. Okay, so it's going to be square root of 144 plus s squared plus, then you hit enter. Alright, now you hit menu, calculus, derivative right here. Okay, check derivative with respect to s, and right here you just type w of s. Hit enter. The answer is right here. Now you need to find the critical number, right? So you're gonna solve the equation w prime of s equals 0, which is this guy right here equals 0, right? So you're gonna hit menu, algebra, solve, right? Then you're gonna copy this one down. Don't forget to define the variable of s, right? Put equal sign and 0. Then put a comma and define the variable s. So hit enter. The answer is 9, right? Now you need to restrict the domain for s value, right? The distance from here to here is 30, right? And distance from here to here is s, right? So s must be greater than 0, less than 30, right? So you have three values of s equals 0, s equals 30, and the critical number s equals 9. Alright, so now I need to evaluate the value of w when s equals 0, right? So I just hit w parenthesis 0 close parenthesis, hit enter. The answer is right here. I want to convert this one to decimal, so I just hit menu, number, convert to decimal, hit enter. The answer is right here. Similarly, I need to find the w of 30. Then hit enter. It's gonna be right here. Again, you need to convert this one to decimal number. Alright, it's gonna be like this. And the last one, s equals 9, right? So w of 9, hit enter. The answer is 50. Now this one is the least value, right? This 53, 60 and 50. So this one is the least value. Now let's move on to example number 5. Rick wants to make Morty a holiday decoration. Rick has 4 feet of wire that can be used to form a square and or a circle. How much of the wire should Rick use for the square, and how much should he use for the circle to create ornaments with the maximum total enclosed area? Alright, now you need to find the primary equation and secondary equation. Remember, secondary equation is what is given, right? Now the secondary equation is 4s, which is the perimeter of the square, right? Plus perimeter of the circle. It's going to be 2 pi r, and total should be 4, which is this one, right? Now the primary equation should be the area of the square plus the area of the circle, right? So it's going to be a equals. Now from the first equation, you need to solve for r. So r equals 4 minus 4s divided by 2 pi. Now I need to simplify this one, so it could be 2 minus 2s divided by pi. I need to substitute this guy over here, so it could be s squared plus pi times 2 minus 2s over pi all together square, right? Now I need to simplify, so this guy turns out to be s squared plus 4 over pi minus 8 over pi times s plus 4 over pi times s squared, right? Now I need to take derivative of this one. So this guy turns out to be 2s minus 8 over pi plus 8 over pi s, right? Now I need to let the first derivative equal 0, so that I'm going to find the critical number, right? So this guy turns out to be 2s minus 8 over pi plus 8 over pi times s, right? Equals 0. Now s equals 4 over pi plus 4. Now keep in mind the range of the wire is 4 feet, right? So the value of s must be between 0 and 1, right? S equals 0. S equals 4 over pi plus 4. And s equals 1, right? Now I have a equals s equals 0, substitute 0 for s into the function a right here. Alright, so it's going to be 4 over pi, right? Now s equals 4 over pi plus 4. I substitute over here. I need to use the calculator, right? Now I need to store the equation a of s first, right? So I need to hit a parenthesis, s close parenthesis, control, and this button right here. And then I have s squared plus 4 over pi. Then hit enter. Alright, now you need to calculate a of 4 over pi plus 4. The answer is right here. Now you need to convert this one to decimal number. So you need to hit menu, number, convert to decimal, hit enter. The answer is 0.56. Similarly, you need to calculate a of 1, right? Hit enter. It's going to be 1, right? I need to convert this one to decimal too, right? So 1.27, right? 1.273. Now observe that the maximum value of error is right here when s equals 0, which means Rick should use all 4 feet of wire to make the circle shape decoration in order to maximize the total enclosed error, right? Now let's move on to example number 6. Your job is to design a right circular cylinder so that it will hold 22 cubic inches of soft drinks, right? So this one is given, which is this one is the secondary equation, right? However, you must conserve the amount of aluminum used to make the can by keeping the outer surface area to a minimum, right? So the primary equation is right here. What radius should the can make this happen, right? So you need to write the secondary equation. Alright, which is the volume of the fluid, right? It's going to be pi r squared times h equals 22, right? Now the primary equation is the outer surface area. So the surface area equals the area of the two bases plus the area around the figure, right? 2 pi r times the height from here to here, right? And this one is a. Now from the first equation, I need to solve for h equals 22 divided by pi r squared. Substitute this one into the second equation. So I have a equals 2 pi r squared plus 2 pi r times 22 divided by pi r square, right? Now I need to simplify this guy. Now I need to take derivative of this one, so a prime should be let this one equal to 0, so that I'm going to find the critical number, right? So I have a prime equals 0 equivalent to, I'm going to multiply both sides by r squared, so this guy turns out to be 4 pi r cubed minus 44 equal to 0, right? So r cubed equals 44 divided by 4 pi, right? It's going to be 11 over pi. Now I'm going to take cube root both sides, so r equals cube root of 11 over pi. Now I need to take the second derivative, so that I'm going to use the second derivative test to determine the maximum or minimum value, right? So I have a double prime, it's going to be 4 pi plus 88 over r cubed, right? Now I need to find a double prime of this value right here. Cube root of 11 over pi, right? If this guy is positive, then I have the minimum value, right? This guy turns out to be 4 pi plus 88 over r cubed, and then when you cube this one, it turns out to be 11 over pi, right? By the second derivative test, the outer surface area obtains the minimum value at the radius equal cube root of 11 over pi, right? Now let's move on to example number 8. A farmer plants 2 planes a rectangular parcel adjacent to a river. See figure right here. The parcel must contain 245,000 square meters, and then this one given, right? This is actually the secondary equation, right? So you have s times y equals 245,000, right? In order to provide enough grass for the herd, what dimensions will require the least amount? So we need to find the minimum value, right? Our fencing, if no fencing is needed along the river, so this one we don't need this one, right? Now we just need this guy and this guy, right? So the primary equation is s plus 2y, right? And I call this one is perimeter, right? Now from this equation I need to solve for y, so y equals 245,000 divided by s. Substitute over here, so I have p equal s plus 2 times 245,000 divided by s, right? Then this guy becomes p equals s plus 490,000 over s, right? Now I need to take derivative of this one, so p prime equals 1 minus 490,000 over s squared. I need to let this one equal to 0 to solve for critical number, right? So I have s squared equals 490,000, right? And I take square root both sides, so s actually equals 700, right? I need to eliminate the negative number, right? Because it doesn't make sense, right? Now I'm going to use the second derivative test to check if this one is the minimum or maximum, right? P double prime is going to be 980,000 over s cubed, right? And I need to calculate p double prime of 700. It's always positive, right? When you substitute 700 for s, right? Then this guy tells us that p obtains the minimum value, right? S equals 700, right? This is what we need, right? Now we need to solve for y, right? So we substitute 700 for s back over here. So y equals 245,000 divided by 700 is going to be 350, right? The dimensions required, the least amount of fencing is 700 by 350, right? Now the last one is example number 12. I'm going to leave this one for you to practice. I just provide you with the answer key, right? The answer is a equals r squared. There are two different ways to solve this one. The first way, you can use calculus like what you just did in previous example, right? And it's good time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand